Prerequisites for intermediate first year Maths 1B. We have coordinate geometry. So, what is coordinate geometry and what are the objectives? Why do we use coordinate geometry? Is first we will discuss coordinate geometry. It is an analytical geometry which links algebra and geometry, representing geometric shapes using ordered pair on a 2D plane. So, what is coordinate geometry? It is an analytical geometry. We have algebra and we have geometry. So, linking these two and analyzing it is what coordinate geometry deals with. So, representing geometrical shapes. So, all the shapes which, whenever the algebraic equation is present, analyzing it and making it into a geometrical shape with ordered pairs on a 2D plane is what coordinate geometry. So, now let's go with the objectives. Locating and applications. Locating points. So, where the ordered pair is present, the x value, y value. So, locating those points. And distance calculation. So, what is the point from one point to other point? What is the distance between them? These can be done. And section formula. Using section formula, you can section it or lie a straight when 2 points are there. If you draw a line, suppose when 2 points are there, if you draw a line and if you want to section them, like you want to divide them into 2 parts, or it could be 3 parts, 2 or 4 parts, so on. So, if you want to divide it into 2 parts, then you will apply this section formula. And midpoint, so as section formula I have already told, section formula is dividing 1 or 2 3 4, how many parts, like that. Just it tells about the mid value. I mean, when it these is of, suppose things this is x1 and this is y1 and this is x2 and this is y2. So midpoint of these two is what midpoint formula gives the value of these points. And slope and line equation. So when it tells the slope and line equation, suppose the diagram is drawn and you have to know the equation of the line. So this coordinate geometry will helps you. And geometric shapes, we have different kinds of shapes. So these geometrical shapes, how it could be drawn, will be known from this coordinate geometry. So first let us understand how can we draw first the coordinate axis. How can we draw coordinate axis is important. So first we have to take two straight lines and draw perpendicularly. How should we draw? Two straight lines should be drawn perpendicularly. That means these two lines should have 90 degrees. Perpendicular is what that, right? So whenever two lines are drawn in a perpendicular line, then we can make it as x-axis. This is x-axis, denote it as x, and this as x dash, and this as y, and this as, sorry, it's just y, and this as y dash. So x dash, y dash, and this is y axis. Okay, this is y axis, this is x axis, this is y axis. The horizontal line that we have drawn is x axis and the vertical line that we have drawn is y axis. So we will get 4 quadrants. First Q1, quadrant 1, quadrant 2, this is quadrant 3, and this is quadrant 4. This is called as Cartesian coordinate system. Suppose let me take a point over here. I'll represent it as P. For suppose now this is a x-axis, right? So from the x-axis, how much distance it has been covered till here is the y distance, right? This much distance is covered, right? These two are parallel lines, so whatever the distance up to till here it is covered, then this is what, think this is as yp. Let us represent it as the distance, I mean this as yp, then it would be also same yp, and whatever the distance from the y-axis to this, then these two are parallel, right? So these two represent as x, let me take it xp, okay? This distance is xp, then it would be xp. So the points could be xp comma yp. Suppose this is the diagram I have drawn, and these are the points. This is y and y dash, this is x and x dash, right? So the P is here. Think if you draw parallel straight line here, then it will be, think it is 3.5 something, the point is, and these as 3, right? So the points could be 3.5 comma 3. This is how we write x and y points. Now I have taken point as here R. Then how can we write the point? This is minus 3. So this x is minus 3 and y is 3. And if I take here Q, then my x and y could be minus 4 comma minus 4. And if I take point here as S, then let me take it as R. It goes in a sequence, right? P, Q, R, S. Then it could be 5 comma minus 3. We can observe over here, right? So we have got how the points could. So in the first quadrant, what you will have observe is the x value and y values are positive. x1 comma y1 will be positive in the first quadrant. In the second quadrant, x is negative and y is positive. In the third quadrant, both x and y are negative, right? And in the fourth quadrant, if you could observe, the y value is negative and the x value is positive. Y value is negative and the x value is positive. So this is how the four quadrants represent points in this way. You should, it's just, if you pass the time, you'll be remembering all those things. Now let's go with the distance between 2 points. So distance between 2 points, P, let us take P x1 and y1 and Q x2 comma y2. That means I'm not taking any positive or negative, just leave it about it. The x value could be negative, positive or negative when the these are the algebra, these are the variables, right? So these variables will have the values could be positive or negative or 0, anything. So when the distance between 2 points, the formula is x1 minus x2 whole square plus y1 minus y2 whole square under root of x1 minus x2 whole square plus y1 minus y2 whole square. So think like it's not like only from P to Q distance, it's also the same Q to P distance. The PQ, the distance from the P to Q and from the Q to P would be the same. It doesn't changes because it's a straight line, right? So when you take from the origin, that is O, from 0, the value will be 0, right? So then if you put, suppose x1 y1, I'm taking this as 3.5 comma 3, or else let me take 5 comma minus 3. I'm taking as value 5 comma minus 3, distance from the origin. So the straight line could be drawn like this, right? This not came in the straight, but the straight line could be drawn. So distance from these 0, O to S would be what? X1 square, the value of these x1 and y1 under root of x1. What is the x1 value? 5 square plus minus 3 whole square. What is the 5 square value? 25 minus 3 plus or minus, it could be the same, that is 9, right? 25 plus 9, that is 34. Under root 34 will be the answer. This is how the px1. Let me take other example for pq. Let me take this as p and this as q. I just wanted to change this value 3.5 because we are starting from now, right? Let me take it as p points as 4 comma 3 and q points as 2 comma 4. Suppose the distance between these 2 points, right? I'm not drawing in the Cartesian plane. I'm just explaining you what is the distance between both of these points. x2 minus x1 whole square plus y2 minus y1 whole square. So what is x2 minus x1? These points, this x1, this is y1, this is x2 and this is y2. So what is x2 value is 2 minus x1 value is 4 whole square plus, actually the formula would be the same, x2 minus x1 or x1 minus x2. You can be written as two things. The answer would be the same because we are squaring over here, right? Even if it is negative or even it is positive, the value could be the same. So it will change as 4 minus 2 whole square and y2 y1 3 minus 4, see, 3 minus 4 whole square. So the answer will be 2 square plus minus 1 whole square, that is under root 4 plus 1, that is root 5. This is how the answer comes. This is how the distance is calculated. When it calculated from x1 comma 0 to x2 comma 0, so the values, y values, see, this y1 and this is y2. If both the values are 0, then x1 minus x2 whole square under root of x1 minus x2 whole square, then these root and square will be cancelled, and modulus of x1 minus x2 will be the distance. If x1 and x2 are zeros, y1 and y2 values are given. Then in the same way these values will be 0 and y1 minus y2 whole square will be written under root of y1 minus y2 whole square. These squares and square root will be cancelled and we'll get the answer modulus of y1 minus y2, that is CD. Modulus represents nothing but making the value, whatever the value is been written, either it is positive or negative, at last we'll write it as positive value. Suppose modulus of minus 6 will be the 6 and modulus of 6 will be 6. Even if it is minus 6, the answer will be 6. Even if it is plus 6, the answer will be 6. Okay, this is how the distance between 2 points is calculated. Section formula is any point from A to B. If we take P as a point, if it divides in any ratio, it could be 1:1 or 1:2 or 2:1, 1:3, 3:1. If the point is dividing in a ratio form, then we use section formula. If this point P is dividing A and B externally, either from this side or from this side, it could be also written, but it has minus AP because it is of distance far, right? Minus AP to PB and AP to minus PB. So what is the formula for it? Just note it down, just understand how it is done. And what is P equal to? The ratio is L:M. If the AP is to PB is what? Equal to L:M. L x2 plus M x1 by L plus M, comma L y2 plus M y1 by L plus 1. Don't forget, first you have to write x2 and then x1. This is how section formula is. Next we will go to the midpoint. If these L and M, if both are 1 and 1, suppose let me take if L is to M is 1:1, then what will be in the place of M? L will write x2, just x2 plus x1 by 2. L plus M is 2, right? Comma y2 plus y1 by L plus M, 1 plus 1 2. This is the same formula, right? x1 plus x2 or x2 plus x1, associative formula, both are same. Area of triangle. If the points are x1 y1 and x2 y2 x3 y3, then this total area will be half modulus of x1. First we'll take x1 and then we'll take y2 and y3. y2 minus x1 into y2 minus y3 plus x2 into y1 minus y3 plus x3 into y1 minus y2. If this is the formula, area of triangle. The next one is if one of the vertices is origin, then the formula is x1 y2 minus x2 y1. It changes, right? Half modulus of x1 y2 minus x2 y1. Next, area of quadrilateral. If we have 4 points, then how could be the formula? Half of modulus of x1 y2, and we are not taking y3, we are just jumping and going to y2 y4. If x1 we have written, then y2 and directly y4 minus y4. Then next plus x2 we are writing. Now we have to write y3, right? Next, following this y3, we are directly jumping to y1, we are neglecting y4. The same way x3 y4 minus y2 plus x4 into y1 minus y3. The formula is shortly written as sigma of x1 into y2 minus y4. Okay. What do you mean by concurrent lines? So first we'll discuss about concurrent lines. The straight lines, if they have common center of any point, then these lines are called concurrent line, and this point where letter V denoted as P is what called point of concurrency. Median or median centroid. So median is from the A point to the next line perpendicularly drawn. That is called median. Three sides are drawn median. So what is the centroid? The point, this concurrency of this point is what? G. The formula will be x1 plus x2 plus x3 by 3 plus y1 plus y2 plus y3 by 3. If angular bisectors in center. So if we draw a triangle and we have an angle, right? Suppose let us take it as 120 degrees. If we half it, that is bisecting. Bi means dividing into half. Sector means two sectors we are dividing, right? So this 120 is divided to 60 and 60. At what point it is dividing, that line is called angular bisector. These three bisectors for B also, for C also, wherever the point it catches, this point is in center. It also forms a circle in middle. It has a radius. This is how angular bisector is denoted. So there is a theorem for in center. If A point x1 y1 b x2 y2 and x3 y3 c are the vertices of A, B, C are respectively the sides of BC, CA and AB of the triangle, then the coordinates of the in center are. So what is the in center value? Ax1 plus bx2 plus cx3 by a plus b plus c, comma ay1 plus by2 plus cy3 by a plus b plus c. So this a b c, a is the value. What is the a value? bc, this value is a, and CA, this value is P, and BA is the AB, or this value is C, the length. Let AB be ECF. AB be, sorry, not AB, it is AD. Okay. Let AD, BE, CF be the bisectors of A, angle B, angle C respectively. Then with the vertical angle theorem, B divides BC in the ratio C is to B. So D will divide BC in the ratio C is to B. So this D is dividing in the ratio C is to B. Then the coordinates of D will be cx3 plus bx2 by c plus b, comma cy3 plus by2 by c plus b. Again the same theorem. This point I on AD divides. Now this we know that point I, if we know the point D, and if we know the point A, then I will divide. How it will be divided? in the ratio b plus c, a of ai is to id, right? Then the coordinates of I are b plus c. Now b plus c into c x3 plus, this is a section formula, okay? Remember, it has a section formula. This is x2 y2, this is x1 y1, okay? This is how it is written. B plus C is to A. The ratio will be B plus C is to A. So, B plus C, this is L x2 plus M x1 by L plus M, comma L y2 plus M y1 by L plus M. What is L is to M? B plus C is to A, right? In place of L, we are rewriting as B plus C, and in the place of x2 value, what is x2 value? This we are writing over here, and then M is to x1 by L plus M, that is B plus C plus A. In the same way, B plus C into y2. What is the y2 value? C y3 plus B y2 by C plus B, right hand, and plus A y1 by B plus C plus A. Okay, so what if we multiply this? We'll get I value as this. How do we? Angular bisector is x-center. So we are angular bisectors, but x-center. That means if A, B, C are there, but we need center as x-center, but externally. Now this is a triangle. This is I1. When you draw a circle over here, B, C are here, right? So then the angular bisectors, whatever the angular bisectors we have drawn earlier, x, see, these are external, right? Angular bisectors. This I point, I1 will be minus A x1 plus B x2 plus C x3 by minus A1 plus B plus C. Same, these are the formulas. Just note it down. You'll get to know in next sessions. If I2, what is I2? If we draw circle over, circle over here, and if we take like this, and from B we are drawing angular bisector, the points where it merges, where it concurrented, this is I2. The same way, if we draw a circle over here, and if we extend the lines, and then we'll draw angular bisector from C, and then we will draw external bisectors of B and A, the point where it concurrented, that is I3. This is how I1, I2 and I3. These are the formulas of it. How to find out them. Okay, and don't worry, A, B, C are the lengths. BC length is A, AC length is B, and AB length is C. Opposite, like AB, then the length will be denoted as small c. The same way other. And altitudes, orthocenter. When we draw an altitude from A to D and B to E and C to F, altitudes are the perpendicular lines. Perpendicular lines which are drawn. So the intersection of these is what called orthocenter. And perpendicular bisectors. Perpendicular, these are perpendicular lines. These are perpendicular bisectors. That means this line whichever we have drawn, it should divide this two, this side half, and BA half, BC half. So the point where these three lines meets, that is called circumcenter, and we can denote it, we can draw it as a circle. It will be a midpoint, that is center of the circle. This is how it relates.